Welcome to my Saturday night, and I'm about ready to develop the cosine graph with you since we ran out of time during class yesterday. As far as the cosine graph goes, I've got my little helping unit circle in the upper right hand corner, and I'm going to make a couple of calibrations right at the beginning on the y-axis. Remember that what's going on the horizontal axis are the angles. These angles will be in radians. And what's going to go on this axis is the cosine of those angles. So let's go to the particular values that we're looking for. If I'm talking about the angle on this axis being 0 radians, I go to where 0 radians are and I look at my ordered pair, and the cosine of 0 radians is the x-coordinate, or that 1. So coming back here, when I'm horizontally lined up with 0 radians, I'm at 1. Okay, and now going along, when I'm at pi over 2, my cosine is going to be the 0. So pi over 2, 0. And then when I go to pi, my x-coordinate is negative 1. So here's a pi, and here's negative 1. And then when I go to 3 pi over 2, it's back to 0 again. That's right back here. And then if I go to 2 pi, which would be all the way around, I'm back to here where the x-coordinate is 1, so the cosine is 1. So back to 2 pi, and that's going to be back to a 1. And I'm going to just talk through and generalize. Can I have angles bigger than 2 pi? Sure. If I went another quarter revolution, I'd be at 5 sets of pi over 2. And then if I went another, I'd be at 6 pi over 2. And these are all places that I've been before, because it's more than a revolution. So it's going to repeat itself. So the graph looks like this. It's going to come get this point. It's going to come get this point, and then it's going to come and finish here. So that is the graph of one cycle, or one period of the cosine graph. But just like what we talked about the sine the other day, since the angles can get larger and larger and be more than a full revolution, the real graph would not stop abruptly right at 2 pi, but would continue on in kind of like this manner. It's hard to do a dotted line when you've never used this software before. And it'll continue like a wave in both directions. So the part that I drew right between 0 and 2 pi was the part that was unique, and then after I got beyond 2 pi, I was being repetitive with something that I had already drawn before. So this is one period of the cosine, also sometimes referred to as one cycle of the cosine. I want to notice that unlike the sine graph, we did the sine graph the other day, and if you remember right, that's one of the graphs you need to be able to produce within 30 seconds. And the sine graph looked like this. It went from a hill to a valley, and basically the hill went up to a certain height, and then the valley was the same depth as the hill. These are the calibrations that you needed. And then the markings on the x-axis always are corresponding with either a peak, a high point, or a low point. or an x-intercept. So this would be your pi over 2, your pi, your 3 pi over 2, and your 2 pi. So I would want you to write those calibrations in. I'll write them in just so you don't use that. There's a reason why you somehow thought I was no longer requiring it. So 3 pi over 2 and 2 pi would be right here. And I would have normally written these right next to the axis, except that I was writing too small, so it was hard. You'll have plenty of space on your quiz on Monday. So this is the sine graph. I want to make a point that sine starts at the origin, and then it goes to a peak right at pi over 2. So something special happens 1/4 of the way through the cycle, it's hitting its peak. Another quarter of the way through the cycle, it's hitting an x-intercept. Another quarter of the cycle, and it's below at its low point, and then another quarter cycle is back up to hitting the axis again. So the sine looks like hill valley. That's how I kind of describe it. As far as cosine goes, it starts at its high point because the cosine of 0 radians happens to be 1, pardon me. So it starts at its height, its maximum height, or 1. And then notice something specific happens every quarter cycle. So 1/4 of the way from 0 to 2 pi, it hits an x-intercept. And then it goes to its low point, and it comes back up and hits the x-intercept in another quarter revolution. And then finally it goes back up to its peak right at the end of one cycle. So I call this, unlike this where I refer to this as hill, then valley, this starts on a half hill, does a full valley, and finishes on the other half of the hill. So that's kind of how I kind of describe its graphs. So let's say that we were in class on Monday and I hand out a piece of paper and say, time for the quiz. Let's go ahead and do that. And basically, if I asked you to graph y equals sine x and y equals cosine x, you remember me saying that I recommend that you calibrate after drawing. So draw a nice smooth hill and then valley for the sine. Mark your calibrations on the x-axis. You should be able to tell when it starts, but you don't have to label that because it's obvious it starts at the origin. Pi over 2, pi, 3 pi over 2, and 2 pi. And then mark the peak, which was 1, and the valley depth, which was -1. If I say produce a quick graph of the cosine, I will have already produced the xy axes. And you just draw a pretty smooth graph. You start at the peak, you do a half hill, you do a full valley, and then you finish on a half hill. Notice I'm trying to make my valley depth be equal to the height hill. I mean, we're not all artists, so I certainly accept, I believe your calibrations for the most part over the artistry that you have. But this is still pi over 2, pi, 3 pi over 2, and 2 pi. And these heights, 1 and -1. So actually let me make those a different color so you don't think that graph continued. So basically, if you produce these calibrations, these 6 calibrations, 4 on the x-axis and 2 on the y-axis, and you draw this graph just the way we have, labeling the coordinates as so, you have full credit on both graphs and you get a 100 on the quiz. So practice these 2 graphs until they can drop right down on the paper inside of 1 minute. And practice that way at home so that you can, practice it as many times as you need to get it under a minute. Good luck, and I hope you have a good rest of your weekend.